Hey guys, here's your guys' Ed puzzle video notes for today. So just in your guys' table of contents, just take a look. So this is the new aspect, right? So um it's homework number 13, Ed puzzle, parallel lines, Converse theorem. So that is what you guys are going to learn today. So just make sure you're writing this in your table of contents so that when I do grade your notes, then everything is pretty much ready to go, right? So, okay, so you guys are going to title it Converse Theorems, okay? Today is September 30th, and pretty much we're almost done with September, right? So, number one. Now, let's talk about the word converse, okay, you guys? So when it says the converse theorem, it's pretty much the reverse of our original statements. So we have the alternate interior angles converse theorem, okay? Which is if alternate interior angles are congruent, then A is parallel to B. Now, what it used to look like, you guys, is if we had at first A and B are parallel, then alternate interior angles are congruent. That's what it was normally. But as you can see, the converse is the reverse. It says if alternate interior angles are congruent first, then we can say A is parallel to B. So instead of having parallel lines first, we have the other statements first, and we can use these converse theorems, you guys, to prove that the two lines are parallel to each other. So if angle 1 is congruent to angle 2, and you guys know those are alternate angles, then that proves A and B are parallel. Okay, now for number 2, this is the alternate exterior angles converse theorem. So if alternate exterior angles are congruent first, then you can say A is parallel to B. And the example, well, based off this image, if angle 1 is congruent to angle 2, those are alternate exterior angles and they're congruent first, then we can say A is parallel to B. Okay, so before we even talk about same side interior angles, right, I have questions for you guys. Okay, so you know same side interior angles, right? If we have parallel lines first, right, then we can say same side interior angles are supplementary. But this is the converse theorem. So if the two angles are supplementary first, then we can say A and B are parallel. So it's pretty much what you guys know, but it's reverse. We used to have parallel lines given to us first, and then we can say those statements. Now we have these different statements, and we can use those different statements to prove we have parallel lines. Okay? Now, for same side exterior angles converse theorem, remember, converse is the reverse. So if we so happen to find that the same side exterior angles are supplementary first, then we can prove that A and B are parallel. So angle 1 and angle 2 are supplementary. If that's true, then we know A and B are parallel. 5, same thing, corresponding angles postulate converse theorem. So if we so happen to find that corresponding angles are congruent first, then we can say A and B are parallel. So tomorrow, you guys, we are going to have proofs tomorrow, and we're going to have some problems you guys can work on in your groups to work on this. So let's take a look at this first one. Okay, so we have a given statement, which is angle 1 is congruent to 7. So we know this is given. Now, it looks like it, you guys, but we're trying to prove that M and N are parallel. So somehow, some way, we have to achieve one of the 5 above. So let's look at angle 1 and 3. Angle 1 and 3. You guys should know by now, oh, those are vertical angles. And we know vertical angles are congruent, right? So, in the next statement, oh, since now we have angle 1 is congruent to 3, now we can say 3 and 7 are congruent because of the transitive property, right? If angle 1 is congruent to 7 and 1 is congruent to 3, then we can say, oh, angle 3 and angle 7 are congruent. And we use lines 1 and 2. Okay, this is what you guys have to recognize. Look at angle 3 and angle 7. Those angles, right? We just proved that those two angles are congruent. Well, what type of angles are those? Those are corresponding angles. And since corresponding angles are congruent right here, we can say, so we know since corresponding angles are congruent, we can say M and N are parallel. Why? Because of the, I didn't even write the numbers here. Corresponding angles postulate converse theorem. So with all of these converse theorems, you guys, anytime you have to prove that two lines are parallel, you have to end it with a converse theorem, because the converse theorems prove that we have parallel lines. Okay, let's try number 2. Oh, so number 2, I'll bring it down because number 2 is using the same sketch. Okay, so number 2. Now, 1 and 6 are supplementary. That's given, right? So, now we have to try to prove that M and N are parallel. Well, in the next statement, you guys, it says 1 and 4 are supplementary. How do you know 1 and 4 are supplementary? Well, you guys, that's a linear pair, right? Do you all agree that it looks like this? Right? If you tilt your head, and it is. So you guys know, oh, linear pairs are supplementary. You guys know linear pairs are supplementary, right? So if 1 and 6 are supplementary and 1 and 4 are supplementary, then you guys can say angle 4 and angle 6 are congruent. Why? Because that, you guys, is the congruence supplement theorem. That is the congruent supplement theorem. So look, we proved that 4 and 6 are congruent, right? What type of angles are those? Those are alternate interior angles. And since we proved alternate interior angles are congruent, we can prove that those two random lines are parallel because of the alternate interior angles converse theorem. Okay, number 3. Okay, so number 3, it says 5 and 2 are supplementary. Okay, that is given. Now, it says 5 and 8 are supplementary. So, how did they figure out that 5 and 8 are supplementary? Because 5 and 8 are linear pairs, and you guys know, oh, linear pairs are supplementary. So 5 and 8 are supplementary. We can say that because we know linear pairs are supplementary. So look at statement 1 and 2. Well, 5 and 2 are supplementary to each other, and 5 and 8 are supplementary to each other. So that means we can say angle 2 and angle 8 are congruent. Why? because of the congruent supplement theorem. Okay, now m and n are parallel because, well, take a look, you guys. 2 and 8 are congruent. We just proved that right there. What type of angles are 2 and 8? 2 and 8 are alternate exterior angles, and we just proved that alternate exterior angles are congruent. So then we can prove m and n are parallel because of the alternate exterior angles converse theorem. So again, it just gets taking use for you guys getting used to practicing, but yeah, so all day tomorrow we are just simply going to be practicing, maybe on Desmos. I still have to take a look, but you know, we'll be practicing and just making sure that we got this. All right, so write these notes down, submit it today, and see you guys on Friday. Peace.